Okay, today we're going to be solving quadratic equations. We've done solving quadratic equations before, right? In fact, we've done it for a long time. We actually know 4 different ways of doing it. Okay? Those 4 ways: factoring, taking square roots, completing the square, and the quadratic formula. Okay? So let's just quick do a review of this. So if we solve by factoring, remember we always had our setup of ax squared plus bx plus c equals 0 to solve by factoring, and had to be set equal to 0, right? We would go through then and we used the x method, right? And you took a times c on top, b on the bottom, and we were looking for those 2 numbers that when we multiply give us a times c, but when we add them give us b. And let's just say those are e and f just for the sake of argument. Okay? So then we rewrote and said, all right, we have ax squared plus ex plus fx plus c equals 0. And then we grouped. And we factored those by grouping. And then we went through and ended up with 2 binomials that equaled 0, right? And then we said, all right, well, that means either the first binomial equals 0 or the second binomial equals 0. And then that was where we were able to solve for x. Remember doing that?
I remember.
Wonderful. Okay, so that was solving by factoring. If we go back then, anybody writing this down? A couple people? All right, so let's go back then and talk about solving by square roots. So we have a whole separate method here. Factoring. Solve by factoring. So the next method we learned was solving by taking square roots. Now, solving by taking square roots came about when we had ax squared plus c equals 0. Okay? Notice there is no x term, right? There's no x term. So that's why we solved by taking square roots. First thing we did is we got that constant to the other side. And we said, all right, well, ax squared equals negative c. And we then divided both sides by whatever coefficient we had. And then we took the square root of both sides. Now remember, when we take the square root of both sides, how many answers do we end up with? 2. So x equaled the positive and negative square root of negative c over a. Now please keep in mind in this example, since I'm just using variable or letters for my numbers, negative c does not necessarily mean that's a negative number, right? That just meant that I subtracted c from both sides at the beginning. So please keep that in mind. But the key idea here is we took the square root of both sides after we got x squared by itself. A lot of you are trying to take the square root of both sides when you have like 6x squared. Well, you can't do that because you're not taking the square root of 6 as well, right? So you got to get rid of that number first, then go through and take the square root. All right. So we had that guy. Let's take a look at another one. Another method that we learned was completing the square. Completing the square, we started out with, I'm just going to rewrite it for the ease of doing it this way, x squared plus bx plus c equals 0. Because the first thing that we wanted to do when completing the square is we wanted to get rid of that number out in front. Okay? And in fact, I would have done it in the second step. I would have said that we have x squared plus bx equals negative c over there, right? And we'd have gone through now and divided out whatever a was. So if we had 2x squared, we would divide everything by 2. If we had 5x squared, I'd divide everything by 5, right? Because we want to get just 1x squared out in front. Because then the goal is that we take x squared plus bx, and we're going to add something. Oops, that's not a 6, that's a c. where we're going to add something to both sides to make it a perfect square trinomial. Now, to find out what we were adding, we also went through and did our factoring step at the same time. So we had x squared, so we bring down an x. So it's in parentheses now squared. The b term is what we put here. We said plus, and we take b and we take half of that. So b divided by 2 is what goes there, right? And then what we're adding to both sides, what's in those blanks, is that we're going to take whatever was down here, this value, half of b, and square that. So b over 2 squared is what we were adding to both sides. Okay, so for example, if this was 6, if b was 6, down here would be 3, and then 3 squared would be 9, we'd put here. So we'd be adding 9 to both sides, right? Okay, and so then at that step, we're going to get something here as well, and then it's just like the previous method where we take the square root of both sides and solve from there. Okay? Questions on completing the square? This should not be new. I'm hoping it's ringing a lot of bells. All right, good deal. So then we had one more method that we learned. One more method that we learned, and the key to this last method was remembering the formula. X equals negative b plus and minus the square root b squared minus 4ac all over 2a. Right? And we always take our quadratic formula from standard form. So ax squared plus bx plus c equals 0. And we plug in the a, b, and c values from our quadratic equation. Okay? Those are our 4 methods that we learned for solving quadratic equations. Any questions? This one? Quadratic formula. Yep, that one's just the quadratic formula.
I feel like there was another one.
No, there were 4 methods. 4 methods for solving. Solved by factoring, solved by taking the square root, solved by completing the square, and solved by the quadratic formula.
We just went through them really fast.
I don't think we went through them very fast. We've been doing this since pretty much the first day of school.
It's not, it's,
8 weeks is fast?
yeah.
Has it really been 8 weeks?
Yeah.
It doesn't feel like it. Yeah, it's only about like.
Yeah, the school year's going by.
All right.
By the boys have been that older than counting.
So, those are the 4 methods we've learned. Also, what we're doing today is going to be then a review of what we've been doing here this last week, which is dealing with imaginary numbers. All right, we've done a lot of stuff with imaginary numbers. We've talked about how to simplify roots using imaginary numbers, how to multiply, subtract, add, divide, all that kind of good stuff with imaginary and complex numbers. That will now come into play with our solutions when solving quadratic equations. If you're solving a quadratic equation and it comes out to be a real number answer, great. If you're solving a quadratic equation and your discriminant ends up being negative, or if you're doing it by completing the square and you end up taking the square root of a negative number, in the past we would stop and say there's no real solutions. But that was before we learned about imaginary solutions, right? And so now we continue on and then get our imaginary solutions. Okay? So let's go ahead. You taking a quick picture of that?
Yeah.
Okay. All right. So let's go ahead then and take a look at solving. All right, down at the bottom of the page, number 18. All right, so taking a look at number 18 in your notes, we have x squared plus 64 equals 0. Look at the instructions. The instructions are great. The instructions say to solve each equation. Does it say solve each equation by factoring? No. Solve each equation by completing the square? No. So we get to choose whichever method we want to do. Okay? So, that being said, what method do you think would be the easiest to solve this equation? Square roots. Thank you for saying that, because that's exactly going to be the easiest method for doing this. There's no x term. So all we need to do is take the square root of both sides. Excuse me, sir. All we need to do is take the square root of both sides. So, well, we can't do that yet. So we have to get the 64 to the other side. So what do we do?
Minus 64.
Yep, subtract 64. And we now have x squared equals negative 64. Now we have x squared by itself. Now we can take the square root of both sides. So the square root of x squared is x. And if I see a negative under the radical, what is the first thing I do? Pull an I out. Pull an I out. So we have I square root of 64. Well, what's the square root of 64?
8.
8. Also, by the way, we put in the radical, didn't we? So how many answers do we get? 2. So it's positive and negative I square root of 64, which means our answer is positive and negative 8I.
Okay, I was going to say, wait, the I does not go first. I was going to say you are useless.
Okay. Questions? Okay, and by the way, you were making a good point. He was saying to himself here that the I does not come first. And so, of course, I wrote it after this. The issue is if I had a radical, if for whatever reason this was my final answer, this is exactly how I would write it. I's come before radicals. Okay, I's come before radicals. They come after whole numbers or integers. Okay, or fractions or anything like that. All right? So, there we go. Questions?
That's easy.
I hope it's easy. Let's try another one.
Well, that one's easy.
Oh, I see. 19. 19. 3x squared plus 27 equals 0. So, we have 3x squared plus 27 equals 0. What's the first thing we need to do here? Well, first off, I guess we need to decide which method we're using.
The square.
Taking the square roots, okay. We could factor out the 3, or we could subtract 27, which is what I'm going to do first. But you're right, we could factor out a 3 first if you wanted to. So I have 3x squared equals negative 27. And rather than factoring out the 3 first, I'm just at this step going to do what now? Divide by 3. Yep. All right, so we now have x squared equals negative 9. We can now take the square root of both sides. So then what does x equal? Positive and negative 3i. And by the way, please, when you say that, it's not positive or negative 3i. It's positive and negative 3i. It's two solutions. Both of them are correct. Okay, some of you, when you talk about these solutions, you think, well, we don't know which one it is. Well, yeah, we do. It's both. Okay? There's two solutions to this equation, not just one. And it's not that we don't know which one it is. It's that there's two solutions. And we know what they both are. Okay? Question?
So if we don't have like this, where it said going back to show we pulled an I out.
Well, not in something that's as simple as this. Right? Yeah.
Just make it
Square root of negative 4, I'm fine if you guys know that it's just 2i. Okay? Yeah.
so we don't get that.
Nope. Okay. Any other questions on this one? One more. One more. All right, taking a look at this one. We now have a trinomial. Okay, so just for giggles, let's go through and try our different methods here. Okay, so our first method is solving by factoring. And so in order to do that, we need to make sure it's in standard form, which it is. Make sure all greatest common factors are factored out and gotten rid of, which they are. And so we take the x. We're going to take 2 times 5, which is 10. Negative 3 goes down below. And we now want two numbers that when we multiply them give us 10, but when we add them give us negative 3. Okay, negative 2 and 5. If I add those, I get positive 3. If I multiply those, I get negative 10. So that doesn't work. Negative 5 and 2. If I add them, I get negative 3. If I multiply them, I get negative 10.
It's all factored out, man. You can't do that.
We can't do anything. Here's the key. There are no real numbers that factor that way. Okay? There's no real numbers that factor that way. So if we could use imaginary numbers, but you know what? I don't want to factor with imaginary numbers, so guess what I'm not going to do? I'm not going to solve by factoring. Okay? All right. I told you we're going to try all these. We're not going to solve it each way. Some of them work better than others for each individual problem. All right, so next, would I be able to solve this by taking the square root?
No.
No. Why? Because there's an x term in this one, so we can't solve it by taking the square root. Okay, so that one doesn't work. Our next method, completing the square. Okay, so if I went through to complete the square, I've got to get rid of that a out in front, right? Yeah, so I'm going to divide everything by 2. That goes away, but, oh man, I now have to deal with a negative 3 halves. And I've got to take half of negative 3 halves. And then I've got to square negative 3 fourths. And I've got to add that. Do you guys want to deal with fractions?
No.
Oh, I didn't think so. So completing the square is not the best method.
So quadratic formula.
Oh, quadratic formula.
Once again.
All right. Now, here's the key thing. Some of these other methods I think are easier at certain times. But there's never going to be one method that is going to be the easiest every time. That's kind of the point I'm trying to make here. Okay? Different methods will be the best choice at different times. Okay? Completing the square, when is that going to be a good choice? Well, it's going to be a good choice if whatever your a value is goes into your b value evenly. So that when you take b divided by a to get rid of that a, it comes out to be a nice integer number, not a fraction. Okay? If that happens, then completing the square maybe is a decent choice. Okay, but if that doesn't happen, then don't complete the square, because then you have to deal with fractions. Okay, it'll work, it's not as easy. All right, so we decided that quadratic formula was our best bet. What is our a value then? 2, our b value. And our c value? 5. So we write down the quadratic formula. Yeah, those of you who are singing this to yourselves as you're writing it, you guys write it the same way as you sing it. X equals negative b. And it's just kind of the formula falls apart. You got to write down the formula exactly as it's stated. A lot of times when I see people writing this down or doing their work here, all of a sudden this plus and minus goes away. People are like, oh, I'll just remember that later. Guess what you don't remember? Plus or minus later on. Or people say, oh yeah, I'll just put the 2a down there later. Guess what you don't remember? 2a. Or I saw some people who remember that there's supposed to be something down there, and they put 2a at the beginning, and they show plugging into 2a, and then later on they just put 2. Okay? Show all your work in every single step. Write down the formula every single step. When you reduce stuff, great, show that reduction, and then write everything else around it. Okay? The more work you show, the less chance you are to make mistakes. So, x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. All right, well, what was our a value? 2 goes there and there. B value? Negative 3. And C? 5. Simplifying, x equals 3 plus and minus the square root of 9 minus what? 40 over 4. What's 9 minus 40?
31. Negative 31.
Negative 31. How do we deal with the negative in there, in the radical?
Taking out.
Pull an I out. So this is I square root of 31. So that means, I'll do an over next to it here, I guess. That means our answer is going to be 3 plus and minus I square root of 31 over 4. But I got to write that as a complex number, right? So I'm going to say 3/4 plus and minus I square root of 34 over 4. Why did I write the I out in front?
31.
Oh, thank you. Yes, it is 31. Why did I write the I out in front?
Because it's a radical.
Because there's a radical there, right? Radicals go behind. Okay? And there's our final answer. Obviously, if those fractions could be reduced, we would reduce them. Okay? Any questions?